Alright, so today we're talking about 4.2, which is amplitude and period. Obviously, we're going to ask any questions. We'll talk about that in class. Any question over the homework. So the first thing we're going to cover, just like we covered yesterday, was with the sine x and cosine x, is like our graphs. Obviously, they repeat. We went over this, pi over 2, pi. Those are our standard positions. Our 90 degrees, our 180, our 270, and right back to the beginning. So we're talking about cosine. If we talk about the period of sine and cosine, we're talking about how far it goes before it starts to repeat, when it will be this 2 pi. So in our amplitude, like we talked about yesterday, it's our distance from 0 to either the top or our distance from our x-axis to the bottom. So that would just be 1. So if we're talking about this, obviously we're not used to seeing this 3. Our 3 refers to our amplitude in our figure. So if we're talking about this, we're talking about if we're going to sketch something like this, let's just go ahead and sketch sine. We know sine, we've sketched it at least 10-15 times in class. We talked about it, so we know it's going to look. We're going to have our same wavy shape. We know we're going to have pi over 2. This is going to be pi. We're going to have our 3 pi over 2 and our 2 pi, where it starts to repeat. So that's our end. So if we look at that, we can kind of get an idea of what our function is going to look like. So if we have an idea of what our function is going to look like, we can kind of do an xy chart. So if we have x and then we have sine x. Okay? So if we put that in, we have our 0 where we start. We have our pi over 2, our pi, our 3 pi over 2, and our 2 pi. So with these numbers, we're going to end up finding where sine of x at these points. So at 0, we're going to have 0. So we know that. So at pi over 2, we're going to end up having 1. So let's go ahead and mark our, so this will be our negative 1 and our 1. And then at these points, we'll end up having, so let's divide our x-axis up. So we have pi over 2. We end up having pi. We have our 3 pi over 2 and our 2 pi. So at these points, we're going to end up graphing our sine. So we end up coming up here to 1. We go back to 0, back down to negative 1, and back up to 0. So we can kind of get an idea of how this is going to look. So there's our sine, curved just like up there in the right corner. So now if we take our points, fill in the rest of this chart, back down to negative 1, back up to 0. So if we take that, and just like with this 3 here, all we have to do is just multiply our whole thing by 3. So if we multiply 3 times 0, we end up getting 0. 3 times 1, we get 3. 3 times 0, get 3, or get 0. 3 times negative 1, we get negative 3. 3 times 0, we get 0 again. So now all we have to do is just adjust our figure. Just adjust our graph. So if we extend our graph a little bit, we go down to, here's negative 2. Here's negative 3. 2. And 3. Obviously my graph got a little skewed, but that's alright. We you have an idea of what I'm talking about. So up here at pi over 2, we still start at 0, but at pi over 2 in our xy chart, we can see we go up to 3, and then we come back down to 0, come back down to negative 3, and back up to 0. So as you can tell, we're starting to kind of get an extension. We're kind of stretching the graph. So if we connect these points, our loops are going to be a little bit bigger. So it's almost like we're grabbing the ends and we're just stretching it apart. So this is going to be kind of the concept of what happens whenever we have this multiplier here in front of our sine, our cosine, or anything else. So let's try another example. So 2 cosine x. So we can do the same thing as we did before. Start at 1. We have our 4 graphing points. So we go down, up, down, and back up. Alright? So this is what our cosine is going to kind of look like between 0 and 2 pi. So what happens whenever we have our 2 cosine? So kind of like the same thing before. Here's our multiplier. So we have our 1 and our negative 1. Alright, so if we're going to just graph our cosine, we end up having the same points as we did before. So our pi over 2, our 3 pi, our pi, did it again. I'm telling you, I got some problems going on. So our 3 pi over 2 and our 2 pi. So at these points, we're going to end up starting at 1. We'll go down to 0. At pi, we come down to here, down to negative 1, back up to 0, and back up to our 1. So we kind of get it just that same graph. And this is just an easy way to follow. This is my process. I want to end up kind of looking at the graph originally and then seeing what we're going to have to end up adjusting for with our 2 here. So if we end up multiplying these by 2, if we start at 1 and we multiply that by 2, we got to go up to we have to go up to 2. If we multiply our 0 by 2, we end up staying at 0. If we multiply our negative 1 by 2, we go down to negative 2. If we multiply our 0 as we come back up, we multiply our 0 by negative 2 again, and we end up getting 0. And we multiply our 1 when we get to 2 pi, we end up getting back up to 2. So we can kind of follow the graph again. So we go through our 0, way down, and stretch back up and back up to our positive 2. So again, we're kind of getting that stretch look. So we end up extending even further up beyond the graph of what we originally have. So as we go forward, we're looking at that stretching vertically. Well, what happens whenever we have something that's less than 1? So we might end up, instead of stretching, or we're still going to have that same thing, it's just going to be a little bit less or whatever. We'll end up talking about that. So what we want to look at, we want to give ourselves a general form to go by. So our y equals a cosine x and a sine x, where all your a is just your amplitude. So that's kind of an easy thing. A equals amplitude. So we're just talking about how far away we are from x-axis to the curve. So if we're talking x-axis to the curve, let's do our sine function just like before. So we can end up doing that xy chart as we have done. So if we end up doing our xy chart, we end up having x and then cosine of x. So we know we start at 1 and we start at 0. We get our 1. We go to pi over 2, we get our 0. We go to pi, we get our negative 1. We go to 3 pi over 2, we're back up to 1, and we end up going down to, or over to 2 pi, we get back to, 3 pi over 2, we'll get back to 0, and then we'll get back up to back to 1 as we get to 2 pi. So all we have to do now is just take those numbers, these numbers right here, and just multiply them. So we just multiply them by 2 times the whole thing. So what do we end up getting? 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 gives us our negative 2. 2 times 0 is our 0. Except now, that's what we would have done in the past. So since we're actually done with 1/2, we're going to end up taking half of this. So we end up getting 1 over 2. And then, let me choose a different color. That seems like it's going to be a little hard to read. So we get our 1 over our 2. We end up multiplying 1/2 times our 0. We get 0. We multiply negative 1 times our 1/2. We're going to get negative 1/2. And then negative 1, or 1/2 times our 0. And then we're going to end up getting 1/2 whenever we multiply by 1. So what's this going to look like? Well, whenever we have our amplitude, a small trick we can always use is right away, we know the highest we're going to get is 1/2. And the lowest we're going to get is negative 1/2. So we can go ahead and fill in the rest of our chart. So we know this is going to be 2 pi, 3 pi over 2, pi, and pi over 2. So we can just follow our pattern. Go all the way, start at 1/2, go to 0, move down to pi, or where negative 1, and move back up to 0, and back up to 1. And then we can just fill in our chart. So now moving forward, now we're going to start talking about period, where the graph makes one complete cycle. So as we go through, we'll end up making one complete cycle. Where do we make one complete cycle for sine? It's 2 pi. That's the reason why. So if we end up using these forms, we can kind of apply what we had before, where the B will be our amplitude, or not our amplitude, our period, and then we can put our A in there also. So then in the future, we can go ahead and move into applying both of them. So this right here is going to end up kind of affecting it. We're not sure whether it's going to stretch us vertically, what it's going to end up doing, but it's going to be something different than what we had before. So if we think about sine of x, we're going to end up thinking about how, our amplitude is going to be our up and down, and our period is going to be left to right, because remember, our 2 pi, our pi over 2, all of those are going to be along our x-axis, so we can say that's our left to right. So since we're moving left to right, we're going to talk about kind of stretching it horizontally instead of vertically. So if we want to just talk about how we can use this to affect our inside, we could talk about, okay, what is inside? We have our 2. Okay, how can we apply this formula here that they've given us? So we use our B. Well, if this is our B is equal to what's inside, kind of like what we talked about up here in these two. So we can end up having 2 pi divided by, and what's inside, 2. And this simplifies to pi. So we know we end up getting, and we always split our graph up into 4 different sections, because that's our 4 key points. So we know that our period is going to end up being pi. So we have to split these up. Well, this is just like splitting, so we can end up saying this is going to be pi over 2 because we split it in half. Then we can half that again, we get pi over 4. And then we can end up getting 3 pi over 4 to fill out the rest of the graph. So, and we know what curve, we know the general form of sine. So we can just fill in our points. Up, middle, down, back to 0. Perfect. So this is going to be our main emphasis, is that we got to know where to plug in our B. And once we plug in our B, we can pretty much just put it in for pi and follow the same curve that we've been doing in the past. So it doesn't really change anything other than our period, which is going to be our numbers down here that we graph by. So if we did the same thing here, what's our B? Our B is 1/3. So if B is equal to 1/3, then our period is going to be equal to 2 pi divided by our 1/3. So we end up taking the reciprocal of 1/3. We end up getting 6 pi. So that's going to be way out here. So if we end up getting 6 pi, that's going to be, you're starting to think, okay, well, that's kind of really far out there. So our graph, is it going to change? Because our amplitude, nothing here is for our amplitude, so it's still 1. So our amplitude is still 1. So we go up to 1 and we go down to -1. So we can fill that in right away. So where we start, we always start at 1. Okay? So let's fill in the rest of our x-axis just to have an idea of where we're splitting it into 4 pieces. So what's half of our 6 pi? It's going to be 3 pi. What's half of 3? It's going to be our 1.5, or it's going to be our 3/2 pi. So we end up adding 3/2 of that, and it's going to end up giving us 9 pi over 2. And then again, we can just follow our same exact pattern. We started at 1, we go to 0, we come down to -1, back up to 0, and back up to 1. Kind of missed my point down there. We'll fill that in, make it all pretty. Hopefully y'all don't complain too much. So this one right here is going to be the ones that we're really going to test you with. Okay, I know you look at this right now and you're going to probably thinking, sitting at home, like, oh my gosh, I'm already, kind of wondering about what we're going to do here with our amplitude. It's got a negative on it. We've got this 1/2 in here, the 3/2. How are we going to end up doing this? Well, the first thing we want to notice, we're sketching it out to 4 pi. Okay, so we could have 2 cycles if we're dealing with our sine. But what's our B? Our B is 1/2. So let's just go ahead and deal with that. So what's our period? Our period is going to be equal to our 2 pi, just like before, 2 pi over our 1/2. Okay? So we end up using this. We get 4 pi. Because we multiply by the reciprocal of this, which is going to be 2. So we end up getting up to 4 pi. So that's where our pi over 4 pi comes from. Okay? So that's just going to be one period for our function. So we can deal with that. So that's how far we're going to go out. We're going to go out to 4 pi. Okay? So let's fill in the rest of our x-axis. So if we half that, we get 2 pi, right? What's half of 2 pi? It's our just pi. And then what's the one we're missing? Everybody can count. 1, 2, 3, 4. So our 3 pi. Okay? So what's our distance? What's our amplitude? How far are we going up from here? We're going up 3 halves. Oh. Okay? And how far is... So whenever we talk about amplitude, remember, it's just this number. We're not worried about this negative yet. We're just dealing with this number. Okay? So, and then we go down to negative 3 halves. So, since we have this, now we kind of have our graph set up. We can kind of follow a trend. Remember, we know what sine looks like. So, if we're just dealing with sine, we can end up sketching our graph. So we start here, we go up, we come down, we go down to negative, we come back up. Alright? But the problem we're going to end up having is this negative. This is where we're going to end up dealing with it. So this is going to be our reflection. So if we think back to like parabolas, if we had negative x squared and we were graphing that, normally we would have this, but since we're rotating over the x, since we have that negative, we end up rotating over the x-axis. So, just like here, here's our original graph. So if we take that and we rotate it over the x, so we rotate these points, we flip them over the x-axis, we're going to end up coming down here. And then for this point, it'll stay because we can't flip it. We flip this point up to here, and then we're back down. Okay? So we start at 0 still. So our zeros never change. It's just our other points. And that's our graph. So that's all we have to remember. We just have to start small and then kind of build back to our main equation where we're graphing from. Okay, where we're headed. If we can start small and use what we know, then we can end up finding these graphs. We don't have to overcomplicate things. Okay, so if we're dealing with this, we're looking for our amplitude, we're looking for our period, and our vertical shift. Okay, when it talks about our vertical shift, we're talking about this. Okay, so this is going to shift us down 1. Okay. So now, same thing as before. We don't want to end up freaking out about all of this. Okay? So, let's just deal with what's inside here, our b. So our b is equal to 1/4. So we know we take 2 pi, we divide it by our 1 over 4. We multiply by the reciprocal of this, which is 4. So that gives us our 8 pi. Okay? And so we have our 8 pi. We end up having our 2 out in front. So that's going to affect where our amplitude is. So, where are we shifting down to? We're shifting down 1. Well, we're going to end up using this at the very end. That's where we just want to deal with our sine right now. So if we end up dealing with our sine, we're going to talk about we start at 0. We go up to 2 because this is going to be our a. We go down to negative 2. Okay? So, if we're dealing with 8 pi, we go out to 8 pi. So that's going to be our period because that's how far we're going to go. That's how far we're going to extend our graph. Alright? So, if we take half of that, we end up getting 4 pi. If we take half of that, we end up getting 2 pi. And then our other one will be 6 pi. So we're counting by 2's up through here. So, if we end up kind of filling this graph in, we start at 0 because we're dealing with sine. We start at 0, we're going to go up to 1. We're going to come back down to 0. Come back down to negative 2. Come back down over to and finish it off. So if we connect this, so this is in general what our graph is going to look like. Okay, and I know Mr. Wilson had talked about don't be doing straight lines, and I know I'm really bad about that, so I try to work on my curves, but I'm trying, so don't hate on me too much. So if we've already got it split up, we've got our amplitude. So what do we got to deal with? What's the only thing we've forgotten? We've dealt with all of here. Now we come to our shift. This is where we get our shift. So our shift is from down 1. Okay? So here's our -1. This is where we're shifting our point to. So if we're shifting our point, it's going to be to here. So this is where we're starting at. Okay? So then we have to shift everything else. Everything else has to shift too. So here's our -3 because we have to shift our point here down to -3. Right here we have to fill in our 1, and we have to shift this one down 1. So we're just shifting everything. So we're shifting this point down 1. We're shifting our point here down 1. So we start here, and we just fill in and connect our points. See, that was a little better, a little bit loopier. Not too bad. Alright, so moving on. Oh no, not tangent. Anything but tangent. I know you hate this, and it's alright, but we'll move past it. We'll get past this. Okay, so now we have a reflection. We know that whenever we see our negative. Okay, we know we shift up 1. Okay, so those are the things we're going to deal with as we get towards the end. Okay, so now that we're shifting up 1 and we're going to end up reflecting, let's go ahead and just worry about what's inside here. What's our amplitude? It's going to be 1. So we know we can fill those in. Okay? And since we have that, we're good. So what we got to deal with? We've got to deal with our b in here. So how are we going to deal with this? We have our 2 pi is equal to our 1/3, and now we multiply by the reciprocal of this, which is 1/3. The reciprocal will be 3, so we end up multiplying and getting 6 pi. Okay? So since we multiply and get 6 pi, that's how far we're going out. Okay? So if we split this in half, we're going to 3 pi. Okay? Split that in half, we're going to 3 pi over 2. Okay? So now if we think about tangent, what we talked about in class, okay? I know a lot of you remember, if we even look at our blue sheet, if we look over there, if we flip it over, we can see the cages, the cage bars, the asymptotes that come down, the lines, alright? So we got to think of where do we have a problem with tangent, okay? And it's always at pi over 2, okay? So if we end up filling, well, let's just go ahead and fill in the rest of this graph. So this is going to end up being, I think, 3, 6. This is going to be our 9 pi over 2. So we know at these pi over 2 parts, we're going to end up having a problem. So remember, when we look at our graph, what's the other thing he talked about? We want to graph it where the origin is. So we want to end up taking the other side. So our 3 pi, or negative 3 pi over 2. So we're talking about the distance between these two is still our full period. So don't worry about, oh, well, we didn't go out to 6 pi. It's not like our normal graph, because remember, at 3 pi over 2, we're going to end up having our cages, our bars, if you want to say, to our graph. So it's going to be in between those two. So since we have that, we know that tangent goes through the origin, and we know that it rises on the right and drops on the left. Okay? So this kind of follows our normal looking tangent, but we still have to deal with our reflection and our shift. That's going to be our big issue. So now that we're there, we've already got this set up. We've got our period, we've got our asymptote set up, we've got our amplitude set up, so we're good there. Now we just have to deal with our other stuff. So let's start dealing with our shift. We're shifting up 1. So if we shift from here up to 1, we start there. Okay? So if we shift up there, that's where we're going to go through. Okay? So we can, do we rise on the right just like we did before and drop on the left? Well, we can, but that's going to end up being the opposite of what we want to do, because we want to do a reflection. Just like we were talking about before. If we did a cubic, if we wanted to find the opposite of it, it's going to end up switching. So it kind of resembles that. So we have to flip these points and this one up to here. So the same thing for here. we want to end up moving these points back down to here. And then we want to end up moving these points up to here. So it's going to be like we're going to end up flipping this line over into our fourth quadrant, and we're going to end up flipping this line into our second quadrant. Okay? So that's how we end up getting it. We dealt with our inside, we just dealt with our tangent, our B, and then we worked out to our reflection, and we worked out to our shifting up by 1. Okay? So now, cosecant. Alright, so I don't want to end up doing cosecant just yet, so we're just going to scribble this out. We're going to put our sign in here. And we're going to end up doing 1/2 sine of 2x plus 1. Okay, so if we do this, this was going to be just, not too different, kind of just similar to what we were doing before. So first thing we want to find, let's do our b. Okay, so our period is going to be 2 pi, just as we did before, over 2. Okay, so that's going to end up simplifying to pi. Okay, so we know we're going to end up going out to pi. Half of that is our pi over 2. Oh, I'm sorry, our pi. And then we're going to end up having pi over 2. And then our 3 pi over 2. 3 pi over 4. So that's going to end up being our period, alright? So that's how far we're going to rotate out. That's how long our cycle is going to be. So we're just going to stay within those. It's going to be the same exact curve because we're just dealing with sine. So how far up? What's our amplitude? We know this is our A. So how far up do we go from the x-axis? We go up to 1/2. We go down to negative 1/2. Okay? Where do we start? We always start at 0. And we always go up. Back to 0. Down to negative 1. Back to 0. So that's going to end up being our sine curve, right? Okay, but now we have to deal with our shift. Okay, so this is us shifting up 1. Okay, so if we shift up 1 from 3/2, how far are we shifting? We're shifting up to shifting up 1 will end up getting up to 3/2. So we just have to extend our graph a little bit. Okay, so all we do, just as we did before, we end up just shifting our points up 1. Let me switch to a different color. So we end up shifting up 1. Shift this one up 1. Shift this one up to 1 from here to up here. And then we shift this up 1. So where are we starting? We're starting at 1/2 now. So we go through, we just follow our curve, and we end up back at 0.